Administration of file systems and security in Linux. Even the most casual user interacts with the file systems of the computer. Anytime we run an application, like a word processor or a web browser, we're reading and possibly writing data on a disk. The security of this data and the system as a whole is one of the prime responsibilities of a system administrator. So that's the two main topics for this nugget. We're going to talk about how to create and manage file systems, and then we're going to talk about security of the file systems and the system as a whole. All right, so let's get started. Okay, so like I just said, first we're going to talk about mounting and managing file systems. And we can't really talk about file systems without also talking about disk partitions and devices. So we'll cover these as one big group. And then we'll talk about security in Linux. First we'll talk about best practices. These are techniques that you should employ to maintain good security in your system. And after that, we'll talk about risks. Even if you employ the best practices, there are still security risks in your system, and you should understand what those are before you get started. Now let's talk about some commands that we can use to manage file systems, partitions, and devices. We use the makefs and fdisk commands to create file systems and partitions, respectively. And then we use the fdisk and fscheck commands to examine partitions and file systems. We use these commands to mount and unmount file systems, partitions, and devices. Now, I was the 6th grade spelling champ, and I know this is not the way you spell unmount, but it is the way that you spell the Linux command for unmount. They just leave out the N for some reason. So the umount command is used to unmount file systems, partitions, and devices. We use these commands to get info on disk usage. The df command tells us how much space in a particular file system is being used, and the du command tells us how much space on a physical disk is being used. And these are just important directories that we're going to need for this discussion, the /mount directory and the /dev directory. Before we go any further, we should answer this question. What is a file system? If this term is confusing to you, that might be because we use the word file system to refer to two very different entities. One of those entities is the directory structure of the computer, and we've seen some of this already. Things like /etc holds config files and /home holds users' home directories, things like that. The directory structure is practically the same on every Linux system. There are some minor variations, but not many. The other meaning of file system is the low-level organization that's used on the disk to store the files and directories. If you want to think of it like this, here's an example. The disk holds a bunch of magnetic impulses, right, like positive or negative charges, and these can be interpreted as zeros and ones. Well, the various file systems, of which some are x2fs, this is probably the most common one that you'll see, x3, which is an extension of that, the riser file system. All these file systems, they can maintain the same directory structure, but what they do differently is they use different low-level data structures to interpret the bits on the disk, if you will. I'm going to use the term file system to refer to both of these, and I'll just make it clear from my discussion whether I'm talking about a directory structure or whether I'm talking about the low-level organization of the disk. To do these commands that mess with the file systems and the partitions, we have to be the root user, so I'm going to switch over to be the root user. And then the other thing that we should check is to make sure that the directory where these utilities are located, we have to make sure that that's in our path. So you can see the makefs utility is in my path. It found it in the /sbin directory. Okay, and you'll see the fdisk command and the fscheck commands, they're also in the /sbin directory. Now first note that this is not the user sbin directory that we've seen before for other system administration utilities. It's just plain old /sbin. Okay, and another thing before we get going here is you have to realize that these commands can do some real damage to your system. When we installed the system, we had the installation program create some partitions for us. If we go back and delete those partitions or try to repartition the partitions or reformat the disks, things like that, that's going to delete a bunch of data, if not all the data on the disk. Okay? So when we use these commands, we have to be really careful and know exactly what we're doing before we do them. So the first thing we're going to do is do the fdisk commands with the lowercase l option. And what this does is it lists all the disks on my system and all the partitions on those disks. And you can see from the result here that I only have one disk. Okay, this is all entry for one disk, and the disk is the dev SDA disk. Okay, what does SDA mean? Well, SDA means the SD stands for a SCSI disk. If that was an HD, it would be an IDE disk. And the A stands for the first disk. So SDA is the first SCSI disk, HDA would be the first IDE disk, SDB would be the second SCSI disk, and so on. Now, looking at this thing here, we can see down below, these three things, these are the three partitions on our SDA disk. It's SDA1, SDA2, and SDA3. The first partition here is the boot partition, and you can tell it's the boot partition because it has an asterisk in the boot column. In this partition, what resides there is the Linux kernel image and also some config files that are needed for startup. And you'll see the size of this partition is 48,000 blocks large. I think a block is a kilobyte, but we'll see for sure later when we do some other stuff. The second partition here, SDA2, is what I would call the main Linux partition. This is where all the user files are located, the log files, things like that. And you can see the size of this partition is huge compared to the boot partition. It's probably 75 to 100 times larger than the boot partition. Okay, now let's see, what else do we want to talk about here? The third partition here is the swap partition. Now this partition, the swap partition, gets used when your main memory fills up. So if you use up all your RAM, you have applications open, Windows open, and all your RAM is used, and then some application needs some more RAM, then what happens is the operating system takes something out of RAM that hasn't been used in a while and writes it to the swap partition. Okay, then that opens up some RAM so your application can use that RAM. If the stuff from the swap partition needs to be in RAM later, then it's brought back in from the swap partition and something else is put out to the swap partition. Okay, so this is like, it just extends your main memory. Now we could get away, in theory, with just one partition, not with three partitions. But here's why we have three partitions. We don't need a swap partition. We could have what's called a swap file instead of a swap partition. But swap files behave much more slowly than a swap partition would. So that's why we have the swap partition, for performance reasons. Now these two partitions, in theory, again, could be condensed into one partition. We could have the boot stuff in the same sector, or in the same partition as the user stuff and the log files and everything. However, on Intel machines, the size of the boot partition is limited, okay? And that limit is actually pretty small. So what's going on here is that we separate out the boot partition because the boot partition on an Intel system must be small, and so all this stuff will fit into that small space, whereas all this stuff wouldn't fit in there, so we create a separate partition for all the user files and the log files and all that stuff. Another way that we can use the fdisk command is to type fdisk and follow it by the name of a disk. So here we're going to talk about the first SCSI disk. So now we're at the fdisk command line, and I can type various letters here to execute various commands. I'll hit M to see the menu of commands. So here you can see there's D for deleting a partition, and N for adding a new partition, P for printing the partition table. This would be kind of like what we saw with fdisk with the lowercase l option. Now, if I deleted a partition, I would definitely be wiping out some data on the disk. If I added a new partition, I would be cutting into the space that some other partition uses, and so again, I could potentially wipe out some data. That's why I said these commands are very sensitive, and you have to know exactly what you're doing when you execute these. Now, one time when I would add a new partition for sure is when I added a new disk to my system. So say I plugged in a new disk. The first thing I would do would be add a new partition on that disk. Okay? After I do that, then what I have to do is I have to format the disk or make a file system on the disk. So let's look at how to do that. I'm going to quit out of the fdisk menu here, and let's look at the man page for makefs. Now makefs, this is what's used to build a Linux file system. And equivalently, this is called formatting a disk when you make a file system on the disk. Now the options for makefs, the capital V option means that we're going to have verbose output, which means it's just going to tell us everything that's going on. The -T option we use to specify a particular file system type. Now if you don't use the -T option, the default is the ext2 file system. That's the most common Linux file system. But if you need some other one, you have to use the -T option to specify it. And then there's other various options, things like we can check for bad blocks, places where the disk is corrupted, things like that. So again, when you're going to add a new disk to the system, the first thing you do is create a partition on the disk, and then you make a file system on that partition so that the operating system can read and write to the partition. The last command of the trilogy of commands that can really mess up your file system if you're not careful is the fscheck command. And this command checks the file system for errors. Okay? What we do is we give it a particular device or partition that we want to check, and here I'm going to check the dev SDA2 partition. Now when I run this,